So the top part of the warm-up was review from last unit, but the bottom part of the warm-up is from this unit. So go ahead and put the Chromebooks away. Earbuds should be away. Cell phones should be away. I shouldn't see any of that. All right. Transformations, what are they? We've got a negative in the front. What is that? Reflect. Reflect over x. It makes it go upside down, right? Reflect over x. What's the 1/2? It's a fraction. What does it do to the graph? It's a compression. It's a vertical compression. It makes the graph really wide, right? So if the graph is this tall normally, it's going to make it half as tall. It's going to take the graph and it's going to squish it, make it look really wide. The +3 inside, what does that do to the graph? Makes it go left 3. And then what about the -4 on the end? Down 4. Okay. What's the vertex? Not 3 and 4. -3. So it's the opposite sign of this number and then the same sign as that number. So -3, -4. Okay. So this graph, it's upside down, right? The domain is the x values. So the domain is left to right. And what x values do we have? Left arrow to a right arrow. -infinity to +infinity, okay? And then for increasing and decreasing intervals, we have to picture our stick figure walking uphill and downhill. These are always x values, so we already said that this is -infinity and +infinity for x values. What's the x value of the vertex? What's the x value of the vertex? -3. And then which side of the graph is the stick figure walking uphill? The left side. Okay, so increasing is over here. So we are not going to use this part of the picture at all. That's the decreasing part. That's not what number 8 is asking about. Number 8 is asking about the increasing part of the picture. So the word increasing is right here. This is where the stick figure is walking uphill. And what numbers do you see on either side of the word increase? What numbers are there? -infinity on the left side, -3 on the right side, and so those are the numbers we put in our answer. And then remember, we put a parenthesis with the -3 because if the stick figure was standing at the very top of the picture, he would not be actively walking uphill. It's in between uphill and downhill. He's not doing one or the other. He's just standing there at the top. Okay? All right. So if we look at our notes from last time, I'm going to remind you of what the notes look like. We have to finish them. So these are the notes that we did on Monday. At the top, they say characteristics of absolute value functions, and this is what we're going to be finishing today. So you need to find those notes because we are going to finish them. They look like this. Characteristics of absolute value functions. Find those notes. We're going to finish them. Characteristics of absolute value functions. Find those notes. We're going to finish them. Find those notes. We're going to finish them. So characteristics of absolute value functions. Characteristics of absolute value functions. You might have some marker on it. I wrote on mine in marker. You might have a color. Yeah, we gotta wait. Yeah. And when you find your notes, we are on the second page. So we did increasing and decreasing. That's where we had the stick figure walking up and down the mountain, uphill, downhill, and we are on to maximum and minimum. All right. Have we found our notes? Quentin, I am shocked. I have. It's, you know, I hole punched these so that you could put them in a binder. I can give you a binder. Yeah. Yeah, I'll give you one after we do this. All right. So maximum. The maximum is the location of the highest value of the function. Remember, whenever they say the word function, they're talking about the y values. So the maximum is whatever point on the graph has the biggest y value. And when we look at this on the graph, you can think of it as a mountaintop. That's what it looks like on the graph. It looks like a mountaintop. The maximum cannot be an arrow. It cannot be an arrow. It has to be a real point. It cannot be an arrow. Not an arrow. Has to be a point. The minimum is the location of the lowest value of the function. The minimum is the location of the lowest value of the function. This looks like the bottom of a valley on the graph. Looks like the bottom of a valley on the graph. It's the same notes that we already took. We're just finishing them. And again, this is not an arrow. Not an arrow. Mm-hmm. All right, so example 5 says to draw an example of an absolute value function that has a maximum of positive 3, negative 2. So write 3 down 2. If it has a maximum of positive 3, negative 2, that means that it would have a mountaintop. So that means this graph would have to be a perfect V shape that is upside down. And positive 3, negative 2 is the very top of the graph. So we would say, for this, if they asked us to find the maximum, we would say, yep, the maximum is positive 3, negative 2. If they asked us to find the minimum, we would say there is none. So that's typically how they do it for these types of problems. They would say, hey, find the maximum and minimum. And you say, well, for a V-shaped graph, you can't have both. You can only have one or the other. So for one, I'm going to have an answer. For the other answer, I'm just going to say none. I'm not going to leave it blank. If I leave it blank, it looks like I don't know how to do it. So I'm not going to leave it blank. I'm going to say none. Then it shows that I know what I'm doing. For the other example, it says to draw an absolute value function that has a minimum. It has to have a valley. And it can be a minimum wherever you want. So I'm just going to graph a point. Doesn't matter where it is. It can be anywhere. And I'm going to make this the bottom of a valley. So my V-shaped graph is going to be going up. And then off to the side, I'm going to say, okay, I'm finding the maximum. I'm finding the minimum. For the maximum, I'm going to say none. There isn't one on this graph. For the minimum, I'm going to look for what that point was for my valley. So mine was -6, -4. You might have put yours in the exact same spot as mine, but you might have put it in a different spot, and it's okay if yours is in a different spot. So one of the answers will always be none. And then for the other one, you'll have an actual answer. It is possible we get to the point later on where we start studying graphs that are called polynomials. And polynomials, they look like this. You can get like multiple curves. And a graph like this would have, here's a mountaintop, here's a mountaintop, here's a mountaintop. So this graph would actually have 3 maximums. You wouldn't just have one, you'd have 3. And then this graph would have a minimum here and a minimum here. It would have 2 minimums. So when you get into more complicated graphs, it is possible to have multiple answers, but these are pretty simple graphs. And so for us, for one of them, we're going to say none, and for the other one, we're going to have an answer. So nothing crazy just yet. But later on, when we study more complicated graphs, we do get to the point where you start to have multiple answers for these. Okay. Wait until we're done with the notes. Okay. All right, makes sense for max and min? We can find those. And then if you notice, the max or min is also in the exact same location as the vertex. And so you can see it from the equation. You can figure out what the max or min is. Okay, go ahead and turn the page. The next thing we're going to do is we're going to find the x-intercept and the y-intercept. And for this, we need our Chromebooks. So go ahead and get your Chromebook out. X-intercept and y-intercept, this is going to be where we use Desmos today. X-intercept and y-intercept. We are going to use our Chromebooks, and we're going to use Desmos. X-intercepts and y-intercepts. So I'm going to go ahead, get Desmos pulled up. So an x-intercept is where the graph crosses the x-axis. The y value is always 0. So the point is going to be written as a number for the x-coordinate and 0 for the y-coordinate. The y-intercept is always where the graph crosses the y-axis. The x value is always 0, so the point is always going to be written as 0 for the x value and a number for the y value. So for example 7, they give us an equation. Now on this one, we don't really need Desmos. We can actually see what the x values for the x-intercepts are here and here. We can see that the x-intercept is at +2 and -6. So for the x-intercepts, I'm going to write -6, 0, +2, 0. That example is pretty simple. For the y-intercept, I can see that it's right here at 0, 2. So x-intercept, x-intercept, y-intercept. So for example 7, those are not too complicated. I purposefully made example 8 a little bit more complicated by putting a pi on the end of the equation. So I forced it so that I would have to get decimal answers for this one. So we're going to have to use Desmos. So let's go ahead and type that equation in. So I've got y equals 2. And then do you guys remember how to get the vertical lines onto Desmos? Anyone remember? We've got two ways we can do it. We can use the keyboard. How do we use the keyboard? So we click on the keyboard down here, and we use the one that's got the lines and the A. And then it'll put them up for you. So we can do x minus 1, okay? Or if you're using the computer keyboard, how do you do it using the computer keyboard? Yeah, shift, and then it's the key above the enter. So if you do shift and then the key above the enter, it will type it for you as well. Okay, now to get the number pi on the Desmos screen, you can use this down here, so to get the minus pi on the end, or you can type pi for pi. It's not pi that you eat, it's the number pi, which is why there's no e on the end. So pi, the number pi, so minus pi, and we'll stick a pi in there. Okay, so there is our graph, and to find the x-intercepts, we just have to click on them. So there's our x-intercepts. We've got negative 0.571, and positive 2.5710. And then for our y-intercept, we've got 0, negative 1.142. So x-intercept and y-intercept. Okay. Were we good with using Desmos to get those intercepts? Okay. Any confusion on anything so far? We are comfortable. The next word, continuity, means that something is continuous. That means it doesn't stop. Continuous means that something doesn't stop. So an absolute value function is continuous if you can start at one arrow, put your finger at one arrow, and get to the other arrow without picking up your finger. So I start here, I trace to the other arrow, I did not have to pick up my finger to get there. So anytime I trace these graphs, they're always just a V, they're very simple. I can always trace from one side of the V to the other without picking up my finger, which means that absolute value functions are always continuous. So it doesn't matter what the equation is. If it's an absolute value equation and they say, is it continuous? Your answer is yes every single time. This is a boring question to ask because the answer will never change. Is the absolute value function continuous? Yes. Wait, I didn't even tell you the equation. Doesn't matter. The answer is yes. Okay? All right. End behavior. End behavior sounds really scary, especially when you look over here and you can see how you write it. You say like as x arrow negative infinity, it starts to look funky. End behavior is describing the arrows. Describing the arrows. That's all you're doing. You're describing the arrows. And we do it with math notation. We're describing the arrows and we're doing it with math notation. So arrows can go two different directions. They can go left and right, that's one direction. They can go up and down, that's another direction. So if an arrow goes to the left, what number do we usually call that? Negative infinity, okay? So if an arrow goes to the left, we would say x, because x is what we usually think of as left and right. We would say x goes to negative infinity. That's what we use for a left arrow. We say x goes to negative infinity for a left arrow. What do you think we would do for a right arrow? x goes to positive infinity. That's what we do for a right arrow. Okay? Now, if we describe up arrows and down arrows, then we use y instead of x. So if we're describing a down arrow, how do you think we do that? Y goes to negative infinity. If we're describing an up arrow, how do you think we do that? Y goes to positive infinity. Okay, so most arrows don't just go to the left or just go to the right or just go up or just go down. Most arrows do two things at one time. So for instance, this arrow right here is going to the left, but it's also going up. It's going to the left, but it's also going up. You guys see that? Okay, so we're going to describe that it's going left and up. So left is x goes to negative infinity. Up is y goes to positive infinity. Okay, so we're going to say x goes to negative infinity, y goes to positive infinity. And then what they do is they make it a math sentence. So they put the word as in front of it. As I look at the left arrow, I can see that it goes up. That's it. The other arrow goes to the right and also goes up. The other arrow goes to the right and also goes up. So for this one, we're going to look at the right and up. So we're going to say, hold on, let me write that as well. Right and up. So to right, so to the right and up, and then to make it a math sentence, I just put as. As I look at the right arrow, I can see that it goes up. So these are the two things we would write, and we call them end behavior, which is just describing what the ends of the graph are doing or describing what the arrows are doing. Okay, how do your brains feel about that? Kind of weird that they wrote it that way? Yeah. Okay. Now this one is a left arrow that goes down. So I'm going to say the left arrow goes down. So for left arrow, I'm going to say left arrow down. Sorry, this is left arrow. And then I'm going to say down. And then I'm going to turn it into a math sentence by writing the word as in front of it. So as I look at the left arrow, I can see that it goes down. As I look at the left arrow, I can see that it goes down. And then I'm going to look at the right arrow, and that one goes down as well. So the right arrow goes down. The right arrow goes down. So as I look at the right arrow, I can see that it goes down. Alyssa, I can see that you're on your phone and the reflection of your glasses. I should chuck her phone out the window. Okay, end behavior, how we doing? It's weird? Yeah. Now, when you do end behavior, the V either goes up or it goes down. So it's only going to be one of these two sets of answers. It's going to be this one or it's going to be this one. Does that mean you should memorize them? No, because we're going to be doing this for every single unit. So you're going to want to understand it at some point. But if you need me to explain this again, I will walk through this again with you. Okay? So the biggest thing to remember is that end behavior is describing the arrows. X is left and right arrows. Y is up and down arrows. That's the biggest thing to remember. Okay, so now we have a practice worksheet that we're going to work on today for the rest of the period that will be due tomorrow. So let me go ahead and hand that out.